Hey guys, welcome back to the channel. So today is Saturday, February 27th, and for the first Saturday, I think all month, we have not had snow. In fact, it's was 40 degrees earlier and raining, so the snow melts off, which is good because, you know, as you guys have seen from my videos, I first fired the heating and snowmelt portion of this up on January 31st, and I played with it. I had everything on, the floors, the slabs, the snowmelt, and you know, I really wanted to get a feel for the snowmelt, how the snowmelt was going to work, what it was going to cost me to run, and it was difficult to do that with the slabs and the staple up on. I did run them for a couple of days, but I ended up shutting them off. If you watched my electrical overview, the way I have this wired and how I do my logging so that I can tell how much it costs is I have the primary loop pump, that Takeo 0013 down there, running through relays, and it's all powered by this smart switch right here. And when this senses the spike in wattage, it sends me a notification and tells me that the primary loop pump is on. The problem is that any one of these three zones can cause that pump to turn on. So for example, these are both calling right now, and that pump is on. Now in a second, when that hits 85, this is my slabs, I have that set to 85 currently. When that hits 85, this is going to shut off, but this is still calling. So the problem is when I'm trying to figure out how long are the heaters running when the snowmelt is on, and how long is, you know, the snowmelt on, and all of that, I really can't get a good feel, good data when I'm not here to watch it, when the other two zones can also call, because then I don't really know which zone is calling. So I shut the slabs and the radiant off for most of the month of February, just so that I could really dial in the snowmelt, play with the aquastat, get the slab surface temperature exactly where I wanted it, get everything kind of dialed in. And my plan was that, you know, in the shoulder months, I guess you could call it, you know, once the snow stopped and I had a couple of weeks where it looks like it wasn't going to snow, I could leave the snowmelt off, fire this up, and really start to dial in and play with the slabs and the radiant. So I've had a few questions about that, about the continuous circulation and about how all of that works. So I figured I'd make a video here today as I'm still dialing it in, to just kind of review and go over exactly what I have this set up to do and how it does it. So when I did the heat loss on the house, I put in a ton of data into a software program I believe called RadiantWorks, and I think it's made by Watts. And I put all my walls in there, all my windows, the U value of the windows, the R value of the walls, just I put everything in there. Size of the walls, ceilings, you know, the R value of the spray foam, the fiberglass, everything that I've got. So I feel like I got a really good heat loss calculation for the house. And then the program has the ability to tell it, what do you want to do? Are you trying to do space heating? So in other words, do you want this to be your primary heat source? Are you just doing floor warming, which is what I'm primarily doing, or are you doing snowmelt? So I ran a report and put in all the data for the driveway, square footage, class 1 or 3, whatever it is, and I can do another video on these reports and show you guys and walk you through exactly how I did it. But it came up with everything that I need, you know, spacing, number of loops, all of that for the snowmelt, gallons a minute, how many feet of head, then I could pick my pump, all of that stuff. Then in a separate RadiantWorks file or package, I did the house, and I put in all the walls, I put in all the ceilings, floor, what type are you heating, you know, staple up without plates, because you can do with plates, without plates. Some of it's slab, the garage is slab. So what I did was I picked all of my staple up, which is my master bedroom, master bathroom, second floor bathroom, kitchen, first floor bathroom, and entryway, all as just floor warming, because this is not my primary source of heat for this house. I don't need this to provide enough BTUs per square foot in order to heat the house. I'm just looking to get the floors to like 80, 82, 83 degrees, somewhere in there. That might even be a little high. I'm still dialing it in, but I basically just want to get the floors warm enough to take the edge off so that they're not cold. The garage, I want to try and get the garage to about 60 degrees. I normally leave it at 58 out there with my Resnor hanging unit heaters. I have one on the first floor and one on the second floor. I think the first floor one is a 40,000, 45,000 BTU, and the one upstairs is like a 30,000. And they keep that garage at 58 degrees all winter, no problems. So, but I do have radiant in the slab that I've never used until now. So the plan was to kind of get the floors to be able to keep that garage around 60 degrees, and then use the Resnor for backup and for those days when I want to go out there and work on a car or something and I want it warmer. I want to be in a t-shirt like I am now. 58 might be a little too chilly. Well, I can turn on the Resnor and bump it up to 70 and it'll do that in like 15 minutes. You know, where radiant, to bump it up to 70 in there, I would need to turn this up like 12 hours before that. I mean, it takes that long to get that slab up to emit that much heat, if it makes sense. So anyway, that was my plan, was to have the radiant do most of the heavy lifting just to maintain the temperature, because it's more efficient, it's a more even heat, and then let the Resnor still be there for those days. Or like in the mornings, once I get the cars back in the garage, we pull the cars out. You know, usually there's a big drop in air temperature. Well, the Resnor might come on for a few minutes and bring that back up. The radiant will help too, but you know, leave that for those. So for the garage in the software, I selected, I wanted the garage as heating, not floor warming, heating. For the basement, I did the same thing. There's no forced air heat runs in my basement. Usually it's a little chilly down here. I mean, it's nothing to complain about. I think I said in another video, I don't know if I made sense. I said, you know, it's not warm down here, but it's not cold. Well, which is it, you know? But it's not horrible. It's not like 40 degrees down here. It's very well insulated, but it could be a little cozier. Okay, so in the software for the basement, I picked heating, space heating for the basement. So all the staple up is just floor warming. The slabs are all heating. Okay, and what the software did was it gave me all of my numbers on that. It told me that, okay, you need a supply temperature of this with a delta T of this, and what those numbers were, if I remember correctly, I don't have the reports in front of me, but it told me for the slabs, I need a supply temperature of about 90 degrees going out, and I believe a delta T of 20. So the swing would be about 20 degrees, but it would keep these two spaces together. And I did put these two spaces on the same zone in the software, so it knows that they're tied together. It knows the heat loss. I put all the garage walls and everything in there too, so the software knows what I'm working with here. It knows they're on the same manifold, same zone, same pump. So I put all that in. Told me for the garage in the basement, I want a supply of 90 and I want a delta T of 20. For the staple up, again, I did not use plates. If this was for my primary heating source for this house, yeah, I might have spent the money and put all the plates in, but it's not. So, and there's a big discussion out there about, do you need plates, do you don't need plates? I've talked to several people. A good friend of mine in Michigan did his whole house no plates, but he's also pushing 120 degree water out all the time. Well, not all the time, but when it needs heat. So again, you know, I don't want to get into the whole debate, just like tankless versus boiler, right? To each their own. For me, I didn't see spending the extra money on the plates and doing all of that when I'm not using this to heat my house. I'm just taking the edge off the floors, and it's working. I can show you on the infrared. The floors right now upstairs are like 82, 83 degrees. And that's after I've got this aquastat dialed in. So anyway, the software told me that for the staple up, I wanted a supply of around 100 degrees and a delta T of 10. So that's where I started with those numbers, with setting these aquastats. Okay, and what I quickly realized was that 90 degrees is too high for the slabs, believe it or not. I have this aquastat set to 85 right now, and so it shuts off when the return gets to 85. Now the supply going out right now is 123 for both, because they're both on. Once one of them drops off, the other one, the supply will jump to 131, because it's able to get more heat across the flat plate, if that makes sense. So, you know, am I limiting my supply? No. Like, the software's telling me I only need 90. Well, I'm giving it 120. So I really don't want the return then at 90 or 100. That's too hot. So right now I have it at 85, and it's been on a few hours today, but it's still coming up to temperature, I would say. And so far it's got the garage at like 60, 61 degrees. And last I checked the basement floors down here, they were getting warm too, so that might even be too high. I might actually have to turn the return. Now remember, this isn't the supply. The aquastats are on the return. So see up here, supply is 123, return is 84. And that's what it says down here, 84. These sensors are pretty much placed right next to each other back here on both of these pumps. And the supply sensor's right here after the bypass. Okay, so as you can see on my staple up, I have that aquastat right now. I started at 100. And what I found was that 100 was not high enough to get me a good floor temperature upstairs that I really liked. So I bumped it up to 105 and eventually 110. And right now I'm at about 111. Again, I got 123 going out. It's 111 coming back. This is reading 111. That's 110. So at 111, this is going to shut off. So it's probably going to shut both of these off while I'm making this video. So, and that'll be cool because you can see what happens. So right now, both of these are calling. They're both pumping. And because of these delta T pumps, I'll explain how those work in a second. They are pretty much at full speed because they're both using about 56 watts. Okay, we're using about 78,000 BTUs total. That's doing the staple up, doing the slabs, and the slabs are still coming up to temperature. I think once those, you know, all that's going to do is cause it to run less. But I currently have the staple up set to a delta T. So like I said, this is right now set to 111 with a delta T differential of 10. Okay, so what that means is at 111, this is going to turn off. It's going to close the valve. And when that bypass valve closes, what you'll see up here happens is the supply temperature will quickly start to come down to equal the return because there's no more supply coming in, it's bypassing. And as that supply and return closes together and gets closer, the pump sees that because I have the differential set to 10. So anything less than a 10-degree difference, the pump is going to slow way down, which is fine because it'll just slowly circulate that 111-degree glycol through the floors. And it'll still be circulating, as you'll see. It doesn't stop, which is the whole continuous circulation part of the system. Okay, but saves a lot of energy. I don't need it to be screaming through there, you know, at 7 gallons a minute. I only really, once it's satisfied and I've got that temperature that I want going through the floors, it can just slowly circulate. It will eventually lose heat to the floors, to the air, to the house, okay, and the return will slowly drop, and then so will the supply, because the return, when it's in bypass, is the supply, basically, right? The return comes back and becomes the supply. So you'll see these drop. I don't know if this video will be long enough to show you, but hopefully they'll kick off here in a second, and I'll show you how they basically become equal very quickly, okay? And then they'll slowly, over a period of a half hour, drop. 111, 110, 109, 108, as they lose heat to the house. And once they hit down to 101, because I have this set at a 10-degree differential right now, once this hits 101, it will say, hey, we need more heat here. The aquastat closes the contact. The three-way valve slowly begins to open to let the glycol now come down through, and at the same time it turns on the primary loop pump, which fires the heaters back up. Okay, so right now we've got about 120 coming in. That's mixed from both. We've got a return of 113. This is reading 113 on the staple up, and 84 on the slabs. So we're getting some, we're stealing some heat across the primary loop from the flat plate. Not all of it, but the tankless units are putting out 140 and they're getting back 120. Okay, so same exact thing with the slabs. Right now we're giving it 123 out because these are both drawn from the same supply. Okay, and that supply right now is just pretty much 123. That's what it's getting. And I have this aquastat currently set to 85, and I have this on a 10-degree differential right now. Now I'm still dialing that in. I might widen that out. I think I set it at 10 because I was trying to bring the slabs up to temperature a little bit quicker so that I could kind of measure floor temperatures before we go to bed tonight, and I could kind of, see how this is going to work. I do think once I get this dialed into the temperature I want, I probably will widen out the differential for the slabs. I think 10 is probably a little too close for concrete slabs because the concrete retains the heat and holds it very well, where the staple up really doesn't, if that makes sense. So anyway, once this hits 85, just like once that hits 111, it's going to shut off the primary loop pump, and it's going to shut off the three-way valve, power to the three-way valve, which the three-way valve will then spring-loaded close and put it in bypass. And what you'll see is the supply will very quickly equal the return, because again, the supply is the return when it's in bypass, right? The pump will see that, and I have the differential on this Delta T pump set to 10. So as soon as it gets 10 or less, this pump's gonna slow way down. And you'll see it. It'll slow right down. It uses basically like nothing. It's when they're close, when they're the same, like if one of these would turn off, they're kind of taking a while right now. Like I said, everything's still coming up to temperature. I've only been playing with this a little bit, but once these two kick off, you will see these equal. The supply will equal the return, and then you'll just watch it slowly lose heat. So for the slabs, you're slowly losing heat to the garage, and I'm slowly losing heat to the basement. Now, one thing I had to kind of consider, and I'm still dialing in, is I've got two very different areas. They're both slabs, but they're very different areas on the same manifold on the same zone, a basement and a garage. So what I've done is I want more heat to go to the garage and less to go to the basement, because you're kind of going to smoke out the basement a little bit if you're constantly providing heat, because the return coming from the garage is much cooler than the return coming from the basement. Okay, so what I do there is I go down and I've slowly restricted the flow a little bit to the basement. Not a lot, but a little bit. And I still may play with it, do it a little more. But the garage is right now is getting about 0.8, and the basement's getting more like 0.6, 0.5, somewhere in there. Okay, so the staple up just hit 111. So that Belimo three-way valve is closing. So it's closed now, it's in bypass. And watch what happens up here. Number one, the BTUs for the units are gonna drop way down because there's not so much of a demand on it anymore. Supply is dropping, 114. The return is 113. Okay, so see how very quickly, like I said, the supply is now the return because it's bypassing. Watch what happens to the pump. And when we were at like 56 watts, we're down to 9 watts and 2 gallons a minute. Okay, and that will usually even go down to like 7 watts. Still pumping, but very slow, and now the supply and the return are equal at 113 degrees. So that'll just continue to pump 113 degree glycol through the staple up, and it will slowly lose heat to the house, slowly. So this will begin to drop. The return will drop to 112, the supply will drop to 112, 111, 110, 109. It'll continue to fall over a period of 10, 15, 20 minutes. And when it needs a little bit more, the aquastat will see it, call for more, it'll come back on. Now, because this one is no longer drawing across the flat plate, all of the flat plate in the heater's 140 degrees can go pretty much to the slabs. Now, it can't get the full 140 degrees across the flat plate, but it can get almost all of it. It can get 129, 130 degrees, okay? So right now it's dumping 130 degrees into the slabs, and I'm thinking any second now you're gonna see that hit 85. It's gonna shut that off. Then the heaters will shut off, because if you watch my electrical system video, whenever any one of the three are calling, it energizes a relay in here which closes the contact and allows power from the pump to the primary loop, or from the outlet to the primary loop pump. Okay, so now this is just going to continue to cycle, this one. And if you go down over here to the staple up, you'll notice they're all pretty much right at 0.2, 0.2, 0.2. We're right at basically 2 gallons a minute. Well, we're at 0.2. So this is at 2 gallons a minute. So if you add up all these, you know, you're at 0.2, 0.4, 0.6, 0.8, 1, 1.2, and then, you know, you've got other losses and stuff. So, and I don't know exactly how accurate this is, but again, we don't need to be burning 50, 60 watts, pumping 7 gallons a minute. I just want that nice, warm, hot, 111 degree glycol to just slowly circulate through these loops until it loses enough heat to where it needs more. And that's where the Delta T pumps are perfect, because they just slow it right down all automatically. So the slabs, again, this is taking a while because, like I said, the slabs take a lot longer to get equaled out, just like the driveway. You know, when I turn the driveway on, it takes a good 3 hours to get that driveway up to temperature. And then I'll notice from my logs, from my data logs, it'll go off for 10 minutes and then on for another half hour. And then the next, there it goes, the next cycle it'll go off for 10 and on for 25 minutes, and then off for 10 and on for 20 minutes. And the gap slowly closes as that driveway heats up. Same thing with these slabs. So watch the supply and return, if you guys can see that. Okay, so the supply is lowering down to whatever the return is, which in this case is 84, should be 85, but close enough. And as it gets within 10 degrees, this 53 watts at 8 gallons a minute will drop. Okay, so now we're below 10. because our return is 84 and now we're 93. So now we're less than 10, and you'll start to see this. You'll start to see this drop. Trying to not show the shadows. You can hear it slow down too. $28. Okay, so now over here we're at 109. We're still circulating and we're slowly losing heat. We're already down to 109 degrees. Okay, so here where our supply is 86, our return is 84. Give it another 10 seconds, these will be equal. This return is bouncing between 84 and 86, so down here we've got 85, so we're right in the ballpark. So we're down to 11 watts, 4 gallons a minute. I mean, for continuous circulation, these pumps are so energy efficient, it just makes sense to just leave them on. Just leave them on and let them circulate. I mean, 10 watts is nothing. You know, these two together, I'm still using less than like a CFL light bulb. You know what I mean? Maybe not an LED, but these CFLs, you know, those things were 19 watts. So, yeah, anyway, I just thought I'd show you guys this while I'm down here playing. I'm still dialing things in. I'll probably go grab the infrared camera, check the floor temperatures, make sure things aren't getting too warm. And, you know, if I find that this loses heat pretty quickly and it's short cycling the heaters where they're firing like 3-4 times an hour, I'll widen out the differentials. I will instead of having them come on at 10 and 10, maybe I'll do like 12 and 20 or 13 and 20, and slowly over the next few days dial this in to where I'm getting a consistent floor temperature in the garage, exactly what I want it. Nice floor temperature in the basement, exactly what I want it. I'm not exceeding, things aren't getting too warm in the house where I'm going over 85 on any of the hardwood. I don't want to do that. I also don't want it to get too warm. You know, this is not my primary heat source, so I don't want to be sleeping at night with the furnace and everything on and it's 96 degrees in my bedroom, you know. So there's a lot of dialing in here that needs to be done, and I'm fortunate enough that I had a good weekend Saturday here without snow, and I've, after the month of February, I mean, February's pretty much over. Today's the 27th, like I said. This February was great to test the Snowmelt out, and for those of you guys that have been commenting a lot, and you know, I've got a bunch of you that I enjoy talking to you guys and responding to your comments, but you know, what a great month to fire this thing up with all the snow that we got and really put it to its test. And I'll do another video, like a usage video, but the usage, I mean, it ran a lot in the month of February, and the dollar amount, I guess you could say, is pretty much right where I thought it would be. Right around, I think it's under $100 extra for the month of February it cost me to run that Snowmelt as many times as I did. So that's cheaper than any plow service I can get, or $20 to call them every time it snows. No damage to the property, none of that. I just flipped a switch, went to bed, came out, everything's good. You guys can watch it on all the time-lapse videos. I mean, it works. It just works great. So anyway, I might come back later on tonight and show you guys once this gets evened out. But as you can see, we're down to 105 here. So once this hits 101, it's probably going to, well, I know it is, it's going to kick these on again. And it really hasn't been off that long. So I might actually go in here. I like the 111 because that's giving me a good floor temperature. But I might actually bump the differential up. Let's bump that up to like, let's go to 11. Give it an extra degree. So now it won't turn things on until it drops to 100. See if that has a huge difference on the floors up there. I mean, you don't want that to get too wide, because then you'll start to notice them cool and heat and cool and heat. I want to try to keep the floors a nice consistent temperature, but I also don't want these things turning on and off and on and off and on and off, where I'm going to kill them. I did talk to Takagi Tech Support. They didn't really give me a number as far as like what's bad for cycling. They did say like 300 cycles a day would be considered excessive, which I got to agree with them. Like when the Snowmelt's on, I don't even think it was running like, I'd have to go back and look, but maybe like 20, 25 cycles a day. You figure it's coming on twice an hour. And, I mean, a lot of those days I didn't even have it on all day. I had it on 6 hours, 10 hours, 12 hours. So, nothing near what I would consider excessive, but this is the first with the Radiant, and the slabs are already down to 81. But again, those are still coming up to temperature. So I think once the slabs really get nice and warm and retain their heat, they're not going to drop so fast. So, but you can see how it's still pumping. 10 watts, 4 gallons a minute, 9 watts, 2 gallons a minute. We're at 104, and we're at 80 over here. 80, 80, 81, 104, 104, 104. And we're still pumping. It's not much, but we are pumping. So once this drops down below what these are set to, it'll kick everything off, fire the heaters, the three-way valves will open, the supply will jump up to 120, 130, whatever it is, either or. The pumps will see that the differential is now more than 10 because I have it set to 10. So when the supply's coming in at 123 like it was and the return's only 104, the pump's going to say, crap, the supply's 20 degrees hotter than the return. I got to start moving here, and it'll slowly move them right up. And this will jump to 58 watts. It'll be up to 9 gallons a minute. It'll really start moving that glycol, getting that heat out. As it gets within 10, it'll start to close, and then eventually the three-way valve will close. It's good to go. So anyway, just a quick one. It probably wasn't quick, but yeah, I just thought I'd show you guys how the Radiant continuous circulation side of things works. And this is what I had in mind when I designed it. So again, yeah, thought you guys might enjoy this side of it. If you like this, give it a thumbs up. Tell me, comment. Like I said, if you got questions, I'd love to answer them. But just so I know if you guys like seeing this sort of stuff. If not, I'm just wasting my time, and I'll just do Snowmelt time-lapse videos. So anyway, hey, thanks for being here, guys. Thanks for watching, and we'll talk to you soon.